I've talked about how in the last video how if I put a magnet in a magnetic field, like for example this small magnet in a compass in a magnetic field coming from another magnet, this compass magnet would experience forces that would cause it to rotate until the magnet is aligned to the field, to the field lines. Now there is another situation in which magnetic force can happen, and that is when there is an electric current, going through a magnetic field. Now to illustrate this idea, now imagine that I have a tabletop here. Let me try and draw a table, just maybe to make it more realistic. So let's say this is a wooden sort of tabletop. I have a big table here. Okay, and these are the legs of the table. These are the legs of my table. Right. Okay. So that's my tabletop. Now on this table, I shall get ready a battery. So let's say this is my battery. Okay, and suppose that this is the positive pole of the battery, and that's the negative pole. So this is the positive pole, that's the negative pole. And then I take a piece of wire, say a piece of copper wire, and I connect one end to the positive pole. Now, and then the other part of the, let me try and draw this again. Imagine that I have a long piece of copper wire now. And one end of the copper wire is connected to the positive pole. The copper wire that we would use for electricity, is usually insulated. There's usually a plastic covering that prevents us from touching the wire, and that prevents one wire from touching another wire. So in this example though, I'm going to think of a bare wire. In other words, there's no insulation here, there's no plastic wrapping. What you see here is supposed to be the copper metal itself. Okay, so if I have another piece of copper metal that touch this copper, electricity might flow from this to another bare copper wire. Okay, so just remind ourselves, this is a bare copper wire. Bare as in not covered with plastic, so we can actually see and touch the wire. And suppose that I have a similar bare copper wire on the other side. And that one is connected to the negative pole. Okay. Now, if you have seen the inside of copper wire, electrical wires before, you might have noticed that in a typical, well, in some of the common wires, you see inside the insulation that it contains of many tiny threads of copper wire sort of put together. Now in this case, I'm not thinking of just that one or many threads of copper wire wrapped together. I'm just thinking of this like a thin copper rod, right? That kind of copper wire. So in effect, I have two thin copper rods down here, and what I'm going to do is I'm going to take another piece of copper. Okay, maybe I'll just make this look different. I'm going to take, say, a piece of thin aluminum rod. Okay, just so I get a different color. I could use copper rod. I'm going to take a piece of aluminum wire, or a very thin piece of aluminum rod, and put it across here. I'm going to put it across here. Now, okay, maybe I won't use an aluminum rod. Now, maybe I'll use a very thin piece of steel rod. Okay, say a thin piece of steel. I'll just say iron rod. A thin iron rod that is quite light and that I can move around quite easily. So this thin iron rod will be touching the two bare copper wires. So obviously, both are since both are conducting, both can conduct electricity. The moment I put this iron rod here, a current will start flowing, an electric current. So going out from the positive pole, and then going from the copper wire to the iron rod, and then going from the iron rod back to the copper wire. So a current will flow. Okay. No, but what has this got to do with a magnetic force? What I'm going to do next is this. Imagine that I take a magnet. I take hopefully a strong piece of magnet, and I put it on top here. I put it over this iron rod. I would probably put it lower, maybe somewhere around here, and that's my north pole. Okay, then this would give me a magnetic field. This would produce a magnetic field that would come down to this iron rod. So if I think of a magnetic field coming down, it would look something like that. Okay, so magnetic field would cover the iron rod. Right. Now the moment I bring my magnet, here, so that the electric field comes down to the iron rod, you will find that the iron rod would start moving. The iron rod will start moving in this direction. And as soon as you take the magnet away, the iron rod will stop moving. So what this means is that this magnetic field actually produces a force on the iron rod. It actually produces a force on the iron rod. Now, if I disconnect this copper wire, right? If I just maybe pull it away from the battery so that there's no more current flowing, then the iron rod will stop moving. So clearly, there must be a current here for the wire to experience a magnetic force. So there must be a current. And then of course, it only happens when we have the magnet around, so there must be a magnetic field. Now I shall represent the strength of this magnetic field by the letter B. I'll talk more about this quantity B in the next video. But for now, I mainly want to describe this situation in which it is actually possible for current going through a magnetic field to experience an electric force. So these are the three main ingredients that we need: magnetic field, electric current, and force.